What's up, y'all? What's up to the LinkedIn people, to the Grayson College people, and to my professors? This is my little kind of lecture for the Chapter 1 Advanced Linux class because I'm a little bit ahead and I really wanted to know the concepts a lot better. So I just wrote a lecture because the really long, like 60-page PowerPoint that is in the Canvas, I didn't like it, so I just made my own. Anyways, here's the video attached with that. Here's my lecture. So hope y'all like it. Now, whoa, Advanced Linux, Chapter 1, all the concepts by me. So, what are we going to learn about? We're going to learn a brief history of Linux. We're going to learn the versions, the flavors, the distros. We're going to learn about some server types. We're going to learn cloud services. We're going to learn about the different jobs you can get in Linux. And we're going to do a brief overview of development using Linux. Now, let's get right into it. Don't be scared. Maybe be a little bit scared, but it kind of will make you better at being scared. Anyways, Linux was originally developed by Linus Torvalds as a Project OS kernel. Hold up. We're going to lock the seat. There we go. By Linus Torvalds as a Project OS kernel in 1991 to combat the strong wave of proprietary software. The Wikipedia page for this is really interesting, by the way, and I really should recommend that y'all go on there and just give it a little skim because it's kind of crazy how they came up with all this. It's a lot of different tools coming together, but we're just going to talk about what's important for the Chapter 1 test. Now, Linux didn't really hit mainstream importance until the X Window system was ported to it. This allowed Linux to adopt a GUI, a graphical user interface. It's also kind of fun to say, GUI. It's just kind of silly. The X Window system is the core of the Linux GUI. It was. Now we have a lot more desktop environments, but in the beginning it was the X Window system was the core for the GUI. Now, when paired with the tools of GNU, the GNU is not Unix is what that stands for, including the copyleft license for Linux, Linux became a mainstay for open source computing. Now, the test wants you to know the different types of software distribution methods. So we're going to go over that because the free ones kind of have a little bit of overlap and they're a little confusing. So open source is the most open of the software types where everything is free including the source code. Freeware is similar, it's also free, but the source code stays proprietary. Things like Cisco Packet Tracer or any free-to-play video game you can ever think of. The game is free, but the code used to make it is not. That is hidden, you cannot get access to it. Shareware is free up front, but usually costs money after a trial period. So just about any free trial software you can think of counts as shareware. So know the difference between those. Know that freeware is free, but the source code is proprietary. In open source, everything is free, the source code is free. It's all open. It's all out there. And shareware is free trials. Finally, Linux now has LUGs, which are the Linux user groups, which are a great way to get Linux information off the internet if you can avoid the egotistical people that talk about Linux. I actually suggest using the Linux user groups for studying for this class because man pages get really boring to read after a while. Now, we're going to get into the next part. Versions, flavors, and distros. I wrote versions into this because versions are a little bit, I'd say, a confusing term when talking about Linux because it gives people this sort of sequential idea of Linux distributions, like Debian, like Ubuntu is a higher version of Debian. That's not exactly the case. It's a different flavor, a different distro of Debian. So I thought I would have to write in here that when updated, software can usually be linked to a version number. Linux's kernel, Linux's tools, etc., they all follow this kind of pattern. It's really just saying when it was last updated, when the particular piece of software was last updated, what version number it's at. Now that makes sense, and I had to mention it because I want to differentiate between versions, flavors, and distros. Flavors are geared towards the Unix because back in the Unix days, there would be multiple flavors, i.e., varieties of the Unix OS. Two that come to mind are FreeBSD and Mac OS. These are your two most popular back in the Unix days. Now, This does extend to Linux as well, but it's less common. This is because Linux varieties are often referred to as distributions or distros. There are many very popular distros, and many are derived from other distros, such as Red Hat, which is the most common enterprise Linux distribution. It does cost money, and it is a lot of proprietary software, but it does have a free version called Fedora, which is technically a different distro. That's why I wanted to specify between versions. Debian is another one which almost a good most of the Linux distributions you'll look into are Debian based. Ubuntu, Mint, Kali, these are all Debian based distros. They're not higher versions of Debian, but they are different distros, distributions of Debian. Ubuntu is the most common server and desktop Linux distro, so you've probably heard of Ubuntu, even if you haven't worked super a lot into Linux. Kali is the most common cybersecurity distro. It's Debian based, and it features a bunch of pre-baked hacking tools like Hashcat and John the Ripper, stuff like that. It's fun, and cybersecurity people use Kali often. Now, this is the hardest part of this entire lecture. I'm going to try to keep it under 15 minutes, the whole thing, not this page. Don't get that scared. It's not too much. You'll probably have to do a little bit of review on here, but I believe in you. It's not going to be the worst. We're going to get through it. We're going to go one server at a time, and hopefully it'll make sense. Now, there are 7 server types on the Chapter 1 test. I'd suggest you do some more reading on them. Firstly, DNS, the Domain Name Server. This is a computer that translates domain names like google.com, linux.com, microsoft.com, other websites to computer identifiable IP addresses and a space before the period for some reason. So 142.251.39.142 is one of the IP addresses for google.com. Whenever you type google.com into your search bar, DNS is the thing that points your computer to 142.251.39.142. Because even though you know google.com, you still need a in-between server to tell you that google.com points to the public IP address 142.251.39.142, and vice versa. DHCP is the Dynamic Host Configuration Protocol. It gives private IP addresses to devices on a LAN, which technically it gives it to a private network, but the differences there aren't major. It gives private IP addresses to devices on a LAN, eliminating the need for manual configuration of IP addresses. This is useful because if you didn't have DHCP, every time you would connect to your Wi-Fi or wire in one of your computers to your router, you would have to manually specify the IP address on that network instead of doing something simple like just plugging it in and it works. When it works, that's because your DHCP server is working. A file server is a computer that exists for the sole purpose of getting files from one part of the network to another. If you want to get them across the internet, you need to use FTP, which is the File Transfer Protocol. Pretty simple. It kind of looks exactly how you would think it is. FTP, File Transfer Protocol. This one is really simple. Of the servers, this is probably the easiest one to understand because it's like connecting your computer. It's like connecting your file explorer to another computer's file explorer. That's what the file server does, is it connects them. Anyways, the next server, the mail server. This is probably, in my opinion, the most complicated technically. Maybe DNS has a similarity in complication, but the mail server is a little annoying because on my PowerPoint here, I said that a computer that stores mail, sends mail, and controls who can access what mail is a mail server. But technically, each one of those functions is a different kind of mail server. You don't need to know that for the test, but I thought I'd mention it because storing mail, sending mail, and controlling the access to the mail are all different servers. By the way, just a little tidbit here. Servers are really just a thing a computer does to send something to another computer. If you are sending something to another computer, you are the server. If you are receiving something from another computer, you are the client. It is that simple. That is what makes a server. A thing getting sent and a thing getting received. That's what makes a server. It's not as complicated as people are making it sound. Anyways, for the test, you need to know that Linux uses MTAs, Mail Transfer Agents, for email routing. A web server is a computer that handles public websites and local services on the internal network. It uses HTML for displaying said websites and services. A web server is going to be your google.com. When you sign into that IP address up there, 142.251.39.142, whenever you go onto there, you're connecting to a web server. Web servers can also be put internally onto your own network. You can get your computers to become a web server and serve to other computers on your network a local service. This is all done using HTML. RAS, or the Remote Access Server, this one is really hard to explain and even harder to write in a sentence. Because a computer that allows computers to access other computers is an accurate representation of what a remote access server is, but it is a little confusing. But it is, and actually, we're going to do a little bit of writing here. So here is your computer. We're going to put U for you little bugger. And over here is the remote access server. We're going to use R for remote access server. Do not confuse that with a router. The remote access server has access to a bunch of resources. So these are all like mini servers. You can say, I don't know, you can make something up in your head. This one right here is your FTP server. This one in the middle is your web server. And this one down here is your mail server. The remote access server has access to all of these servers. Now, it's really just a server. It's a reverse proxy server if you want to get technical, but you don't need to know that. So you, the user, accesses the remote access server remotely. This little line here comes over the internet, meaning you're accessing it outside of the network. And the remote access server has access to all of the servers you could ever dream of using. And because of that, that's what makes it this is the computer that allows computers to access other computers over the local network. In Linux, you're going to be using Telnet or SSH, which are both terminal servers, terminal remote access servers. I hope that explanation was good. It took me 3 minutes, but it's confusing. I understand. Proxy server is the opposite of what I just said. This type of computer acts as a sort of fall guy, acting as your computer on the internet. It masks your IP address, caches data for fast access, kind of like NordVPN. So the other server was from the outside going into the network. A proxy is a computer from inside the network needs to go to the proxy, and the proxy accesses the network, or the internet for the internal servers. Those are the servers. That's really scary. That's really complicated. That is a wall of text. Daunting, I understand, but just do a little bit of Google searching. I probably explained a few of these concepts a little vaguely because it's boiled down so that I could say it quickly. Do some research. I promise you, it's not that complicated. These are all fun things, and if you can know all of these servers, it'll help you out in your jobs. Now, we have already been talking for 14 minutes, so let's keep going. Nothing in these lectures, by the way, is going to be as hard as that page. Now, the basic cloud services. We're going to get a quick definition of the cloud real quick. The cloud is literally purchasing access to someone else's computer because it is better or more reliable than your own. Better if you need a lot of compute power, or more reliable if you need storage that you know is not going to get destroyed if your house burns down, if your computer blows up because you're running CS at maximum possible fidelity with 500 frames per second, overclocked, If you need to do that through a cloud server, I don't know why you would, but hey, that'd be pretty cool and it'd make a good YouTube video. And more reliable for your data. Let's get into the different ways you can access these computers. Software as a service, SAS or SaaS. When you purchase access to someone else's computers, this access is used through a software. Think Google Drive, OneDrive, iCloud storage. I noticed that all three of those, by the way, I'm going to keep this marker up. This thing's awesome. I love this. These are all storage types, which is the most common SaaS. Whenever you ask people about SaaS, these are the ones that jump to mind. But anytime you're accessing another computer through a software, it's an SaaS. Now, Adobe anything is all SaaS. Photoshop, Premiere Pro, that's all SaaS because a lot of the computing for those doesn't get done locally. Now, my favorite, Xbox Live is also an example of an SaaS because you can't access the online portion of Xbox without Xbox Live. Therefore, it is an SaaS. You have to go through Microsoft's local computers to get to Microsoft servers, which Microsoft servers are just Microsoft's computers. Let's keep going. Infrastructure as a service, IaaS. When you purchase an elastic amount of computer resources from someone else and you have near full control over the usage. Infrastructure as a service is quite literally what it sounds like, but it's more useful to you if you don't want to, one, purchase a massive infrastructure of computers, or if you don't want to, you know, or if you need to use the infrastructure for a very short amount of time. You don't want millions of dollars of infrastructure to do a thing for you. But if you need millions of dollars of infrastructure for like 2 days, infrastructure as a service is a great way to get that. It gives you near full control over everything on the computers. And some good examples, and you may have heard of some of these and you may not have heard of the others, but AWS, Amazon Web Services, they recently had an outage, which would actually make you know about them a little better. Azure, which is Microsoft's IaaS. GCE, the Google Cloud Engine, which is the IaaS for Google. And Oracle Cloud, which is used in some really weird places, I got to admit. You might see Oracle Cloud in just the most unexpected places. But these are your IaaSs. Now, the next is PaaS, Platform as a Service. It's very similar to IaaS, but with slightly less control over the computers of the cloud provider. Usually, it has a proprietary OS with proprietary development tools. It's seen with like containerized applications, which are kind of like mini operating systems that you just need to run a service through the little containers. So it's but PaaS is in between SaaS and IaaS because you can't download operating systems onto PaaS like you can on IaaS, but you can also specify what software is being put on this platform, so you can define the software, unlike SaaS, which the software is already defined for you. This is done with containers, little mini computers. Really cool. Now, I don't want this to get past 20 minutes, but we're at 18 minutes and 33 seconds, so we're going to keep on going. Also, just so you know, this is really important. You do need to know this for like jobs and stuff. This is a very important concept. Anyways, jobs with Linux. The most common folks to use Linux on the job, aside from the Linux admins, because duh, that's all they do, are your software developers. Just about everything with Linux is free. The OS itself, licensing, updating, most software with Linux is free. So the main cost of Linux is just paying the people who work with it. This isn't to say that it's different from Windows, because you will still need Windows administrators, but on top of needing Windows administrators, you also have to pay for Windows. But the only cost in Linux is paying for the people who work on Linux, which makes it cheaper, and software developers really like it because then they don't have to pay for their own licensing. They can just do it. They can just get to it. Get cracking. What kind of jobs do you see working with Linux? DevOps. These are the people that manage the workflow where software is added to the cloud because they are operators of the systems for the web app development. They are development operators, so to speak. That's actually on the test. Just gonna give you a little throw out there. Cloud engineer designs the large computer systems and their connectivity to securely and quickly distribute cloud services to the customers. These are the people designing the clouds and the computers that go with the clouds. And your integration specialists, they work on integrating different platforms together, including Linux with other OSs like Windows. And I don't know, I don't actually really know. Temple OS, yeah, that's cool. Integration specialists don't work with Temple OS, but wouldn't it be cool if they did? They they make multiple operating systems and platforms operate seamlessly. That's what integration specialists do. Now, we're almost done. This is the last slide, so don't freak out. And if you're crying, please stop because you can watch the video again. Anyways, all right. This slide isn't Linux focused per se, but it is important for the test. So included here, very simply. When developers are constantly pushing new web apps to the cloud, this is called continuous deployment because they are continuously deploying web applications to the cloud. Makes sense. When developers are constantly integrating their apps into new systems, operating systems, and testing on new platforms, this is called continuous integration, CI. Now, these updates are often numbered using different types of version numbers. Minor numbers, a small tweak to a bit of code that does not change the function all that much, like adding a tab for readability or changing a comment. Not things that are changing how it works very much. Major numbers, these are large changes to the code that change the function or make it drastically faster, more scalable, or just completely changes the process, like going from Python to assembly. Complete major number change right there. Or you're going to number it with a major number. Anyways, this one is different than the other two. The release candidate number, this is Linux based. A candidate for a kernel release is a release candidate. Makes sense. Not fully stable and still in development, but mostly done. Literally a candidate kernel for being released. I felt the need to really talk about this one because we're almost done and we're going to keep this under 25 minutes, which is great. A release candidate number is the number of the release candidate. So usually whenever Linux people are developing kernels, they come up with multiple release candidates, multiple kernels that could be released. Usually you'll have these can go up into the hundreds, but usually it'll be like you have release candidate 8, release candidate 7, release candidate 6, release candidate 5. These are all kernels that could be released. They're all in a developmental form. They're not ready to be released, but they could be released. And the release candidate number is just the number identifying which candidate it was, which candidate it is in the release number. It makes sense. It's pretty simple. Just a possible kernel that could be released, and then the number to identify it. It doesn't signal sequentialness. It is possible that you could have release candidate number 5 that hit before release candidate number 2. It's just an identifier for that particular candidate. Anyways, that's it. Want to keep ink annotations? No, I don't. That's it. That's all you need to know for the chapter 1 test. I think there's a few things in there that are that are not on this. I'm not gonna lie to y'all. Sorry, couldn't get everything. There's a few like random things on there that are unrelated to anything I just talked about, but there's not much. And that right there should cover everything you need. If you're on LinkedIn, I hope you watched that. That was a long video, so I wouldn't be shocked if you didn't. But there you go. Chapter 2 coming soon. Maybe, maybe not. I might just stop here.